Welcome back, dear students. Under Algebra and Number Theory, we are in Unit 2, Finite Fields and Polynomials, in lecture number 6. So here we are going to see when a polynomial is divided, we can write the polynomial as a product of its roots. So let's get on to the presentation. So the first problem, what is the remainder when f of x is equal to x power 5 plus 2x cube plus x square plus 2x plus 3 in z5 of x when divided by x minus 1. It's a very small problem and it's very easy to handle it. So given a polynomial is given to you and it is also divided by another polynomial. Okay, in the previous lectures we had divided, we have used long division method and we had found out the remainder. But suppose if the weightage of the problem comes as 2 marks, you need not to do all such things. Just you got to get your remainder. Very simple. When f of x is divided by x minus 1, right, the remainder is f of 1. Clear? Therefore, what will I do? I will just substitute 1 over there. So if I just substitute 1 in place of x, what will be my answer? 1 plus 2 plus 1 plus 2 plus 3. So my answer comes up to 9. 9 is not allowed in Z5. You know that. So you got to divide it over 5 and your answer is 4. Therefore the remainder is 4. Very simple problem and very easy to handle also. Second problem in the same pattern. What is the remainder when f of x is a cubic equation and Z5 of x is divided by x minus 2. So what do? It's just the weightage of the problem is 2 marks. So f of x is equal to 2x cube plus x square plus 2x plus 3 in Z5. So Z5 numbers are 0 to 4. So now when it is divided by x minus 2, the remainder is f of 2. So what will happen? Substitute 2 in place of x. So your answer comes to 27. So but this 27 is not allowed in this Z5 set. So you divide by 5. So you are getting the answer as 2. Just a small mistake. It's going to be 5 here. So 2 mod 5. So 2 is a remainder in Z5. So now the third problem. If f of x is equal to a third degree polynomial, then write f of x as a product of first degree polynomials. It's an important problem. So first degree polynomials in the sense all linear equations. So x should not have any power. So now how we are going to find out the roots? So what you're supposed to do is take Z7. So since it's mentioned as Z7, we write down all the elements of Z7. 0 to 6. Now the polynomial is given. Now what you do? Start substituting 1 by 1. Okay. So if I'm going to substitute 0 to that particular polynomial, what is my answer? My answer is 6. So answer is 6. So which is 6 allowed inside Z7? Yes, it is. 6 is allowed inside Z6, which is not equal to 0. So 0 is not a root. Now substitute 1. Now substitute 1, my answer is 14. So 14 over mod 7, my remainder is 0. Therefore, I say 1 is a root of f of x. So if 1 is a root, I can write x minus 1 is a factor. Okay, hope you're getting it. Then substitute the next number 2. So if I'm going to substitute the second number 2, my answer is 38. 38 is not allowed in the set. So I'm going to divide 38 over 7. Okay. So now what will happen? 35 and the remainder is 3. So 3 is not equal to 0. So which means 2 is not a factor. Okay. 2 is not a root and therefore we cannot find a factor. So from 0 to 2 we have only one root. 1 is the root and x minus 1 is a factor. We'll proceed with the other left out numbers. Now take up 3 there. Substitute 3. Your answer is 84. Perfectly divisible by 7 and your remainder is 0. So therefore 3 is the root of f of x. Therefore I can write x minus 3 as a factor. Now go to 4. 4, my value is 128. My remainder is 2 when I divide it by 7 and hence 4 is not a root for me. And f of 5. Substitute 5. 266, which is perfectly divisible by 7. Therefore 5 is a root. Therefore I can write x minus 5 is a factor. Then coming to f of 6. F of 6, if you take x cube plus 5x square etc. and the value comes to 414. When divided by 7, the remainder is 1. Therefore 6 is not a root. So totally what are the roots we have found out? 1 was a root, 3 is a root and 5 is a root. So therefore x minus 1 is a factor, x minus 3 is a factor, and x minus 5 is a factor. So it's enough you write it as a product of these factors. Therefore f of x, the given polynomial, this is how I conclude my answer. The given polynomial f of x can be written as the product of the linear factors, which means x minus 1 into x minus 3 into x minus 5 in Z7. This should be clearly mentioned. In Z7 only we are doing it. So in Z7 we got the three linear polynomials as the answer. Hope you understood. Move on to the next problem. Now if f of x is given as a product of three polynomials, see how it is represented. So there are three brackets and three brackets contains different polynomials. In Z7 they are saying. Then write f of x as a product of a unit and three monic polynomials. This idea is also important. So how do I say what is a monic polynomial? I hope everyone remembers the word monic polynomial. So to understand the concept of monic polynomial, we should know what is leading coefficient. So what is a leading coefficient? Leading coefficient is the coefficient of the highest degree term, right? And if the leading coefficient is 1, that is the highest degree term, coefficient is 1, then that particular polynomial is said to be a monic polynomial. So now what are we supposed to do with this particular problem? So first write down all this f of x three brackets functions in Z7 and you state what is Z7. It's starting from 0, 1, 2, 3, 4, 5, 6, right? To write f of x as a product of three monic polynomials, what are we supposed to do? Can you just have a guess? So suppose if this has to be a monic polynomial, which is the highest degree term in the first bracket? X square, right? Then the coefficient here is 2. Then it cannot be called as a monic polynomial. So what is creating a problem here? 2 is creating a problem. So if this 2 has been made 1, then it will be a monic polynomial. Likewise, in my second bracket, which is the highest degree term? X cube is its highest degree term. So 5 is creating a problem for me. Likewise, in the third bracket, the highest degree term is x, whereas the coefficient is 4. Again, 4 is creating a problem. So if I don't have 2 and if I don't have 5 and if I don't have 4, then automatically these three polynomials will be called as the monic polynomials. So now it is not like in that case. So we have to do it. We have to replace these numbers in terms of 1. So how will I replace this? So if I want to make this as a monic polynomial, I got to take this 2 outside of this bracket, correct? If I'm going to take 2 out of this bracket, this will become x square, right? But now what will happen to this one? As I told you, whenever you're coming with a fraction, you have to treat the numerator as a remainder. So find out that particular number when divided over 7 yielded the remainder 1. Which was that number? That was 8. Able to understand? Only if it was 8 there, then if you are going to divide it by 7, the remainder was 7. So that's what the representation here happens. 2 from 2x square plus 1, I'm going to take 5 from 5x cube plus 5x plus 3 and 4 from 4x minus 3. So 1 if I'm going to, so this is going to be 1 has to be replaced by 8 of mod 7 and 5 if I'm going to take from this won't be an issue, this won't be an issue, but this will definitely be an issue. 3. So plus 3. So what was the number which yielded the remainder 3 when divided by 7? It was 10. Correct? Okay. Then finally coming to minus 3. So minus 3 can be written as 4 short of 7. So write it like this. So now what do I do? Replace all the particular numbers 8, 10 and plus 4 and divide and taking now 2 you can take out. Very well you can take 2 out here. So it will be x square plus 4. And here if I am going to take 5, it will be x cube plus x plus 2. Here you take 4 times of x plus 1. So multiply the terms, the numbers which are outside the bracket. 2 5 is 10 and 10 4 is 40 and the rest of the numbers followed. Again 40 is not allowed here under modulo number. So we are going to divide it by 7 and remainder is 5. So this is the given polynomial f of x is written as the product of the three monic polynomials. Just a note to be written. So instead in the third factor we had written it as minus 3 and I have mentioned that it is 4 short of 7, right? So that can also be written as 24 if it is plus 3. So that also can be done. Okay. Hope you understood. Thanks for watching. We'll continue in the next lecture.